Hi guys, hope you like the first video and this is our second video and this also will be about the basic of statistics part 2 and here the instructor will be continuing about the part 2 on the basic of statistics and here the starting will be of sample distribution and the projection, okay, and then it will be continued up to some slides, then there will be the third part which will be the finisher for everything. Okay guys, please like, share and subscribe this channel such that we can be more motivated and your friends can be also being taught what is statistics. Thank you guys.
Good afternoon, friends. This is our second continuation of Introduction of Statistics. I'm going to talk about population and sample distribution. What is population distribution? Frequency distribution of the population. Sample distribution, distribution of the sample. Sample distribution is a blurry photo of the population distribution. As the sample size increases, the sample distribution becomes closer representative of the population distribution. Sample of population distribution can be summarized by describing its shape based on the graph. It can be symmetric or non-symmetric, skewed to left, right, based on its tail. This is here graphical representation, properties of numerical data and measures, central tendency and dispersion and shape. Central tendency means mean, median, mode, and dispersion range, interquartile range, standard deviation, and shape, skewness, kurtosis. We'll move on to next slide. Measures of center. Central tendency mean sum of observed values in a data divided by the number of observations. Median, observations in the data set that divides the data into half. Suppose if your data is not belongs to normal distribution, parametric, then we have to see the median value. Median observation in the data set that divides the data set into half. Mode, value of the data set which occurs with greatest frequency. Mean and median can be applied only to a quantitative data. Mode can be used either to qualitative or quantitative data. What to choose? Qualitative variable mode. Quantitative with symmetric distribution mean. Quantitative with skewed distribution median. An outlier. Observation that falls far from the rest of the data, mean gets highly influenced by the outlier. We use sample mean, median and mode to estimate the population mean, median and mode. Measures of dispersion. Dispersion. It is spread variability of values above the measures of central tendency. They quantify the variability of the distribution. Measures include range, sample interquartile range, standard deviation, mostly used for quantitative data. Range, difference between the largest observed value in the data set and the smallest one. So, while considering range, great deal of information is ignored. Interquartile range, difference between the first and third quartiles of the variable. Percentile, divides the observed values into hundreds, 100 equal parts. Deciles, divides the observed values into tens, 10 equal parts. Quartiles, divides the observed values into 4 equal parts. Q1 divides the bottom 25% of the observed values from top 75%. Standard deviation, It is a kind of average of the absolute deviation of observed values from the mean of the variables. So here we can find out how much deviation from the mean of the particular variable. It is defined using a sample mean, and values get strongly affected by few extreme observations. Shape. Skewness, lack of symmetry in the distribution. It can be interpreted from frequency polygon. Properties. Mean, median and mode fall at different points. Quartiles are not equidistant from median. Curve is not symmetrical but stretched more to one side. Distribution may be positively or negatively skewed. Limits for coefficient of skewness is plus or minus 3. Kurtosis. Convexity of a curve gives an idea about the flatness, peakedness of the curve. Normal distribution. Bell-shaped symmetric distribution. Why is it is very important? Many things are normally distributed or very close to it. It is easy to work with mathematically. Most inferential statistical methods make use of properties of the normal distribution. Mean is equal to median is equal to mode. 68.2% of the values lie within one standard deviation. 95.4% of the values lie within two standard deviation. 99.7% of the values lie within 3 standard deviation. Test to check normal distribution. Checking measures of central tendency, skewness and kurtosis. 2. Graphical evaluation, normal plot, frequency polygon. Statistical tests. Kolmogorov-Smirnov test, Shapiro-Wilk test, Lilliefors test, Pearson chi-square test. Shapiro-Wilk is the best power for the significance. It is if normally distributed, correction of transformation by the data. We are using log transformation. That means if a distribution, if a continuous variable is normally distributed, so it is not a parametrical, then we will do, there are two transformation. One is called log transformation using log values. Another is square root of the variable. That continuous variable will be square root. Then that particular variable will be formed. That is called square root transformation. My dear friends, I'll tell you, this is an overview of the introduction of statistics. Because data science needs a total package of statistics. I don't want to give very simple. This is I am giving only overview. Normal distribution I am going to take a separate chapter. Because it is a very very important one. Normality checking, before that you should know what is normal distribution. That will be taken as a special another chapter. These are the things only I am giving basic. Like that I am giving for hypothesis testing. The aim of doing of study. I want to do a study. What is your aim? Is to check whether the data agree with certain predictions. These predictions are called hypotheses. Suppose I am having 100 data with respect to diabetic patients. All the patients details data, all the parameters obtained from Government Kidpark Medical College Hospital, Diabetic Department. So, my vested interest, what is my hypothesis? First, I will see the prevalence of peripheral neuropathy, one disorder with respect to foot of the patients. Those who are having diabetic will have lot of disorders. This is the theory. So, based on this medical theory, as a researcher, I want to know first prevalence of peripheral neuropathy and what are the associated risk factors with respect to peripheral neuropathy. Here one hypothesis, first I am going to see duration of diabetics. So my hypothesis is there is no statistically significant difference between peripheral neuropathy and no peripheral neuropathy with respect to the duration of diabetics. Suppose duration diabetes increases or lesses, it is not a factor. This is my null hypothesis. Significance test. This is only example. Detailed example will be given here and there when I am going to take all the hypothesis analysis and separate chapter will be there. So that time I will give lot of medical and non-medical examples so that you can understand and you can apply in your practical life, dear friends. And significance test. It is a way of statistically testing and hypothesis by comparing the data values. It consists of two hypotheses. One is called null hypothesis, that is always denoted as H0. Another is alternative hypothesis, that is always denoted by H1. Null hypothesis is usually a statement that the parameter has value corresponding to, in some sense, no effect. Alternative hypothesis is a hypothesis contradicts the null hypothesis. It is opposite to our null hypothesis. Alternative hypotheses are formulated before collecting the data. Significant test analyzes the strength of the sample evidences against the null hypothesis. The test is conducted to investigate whether the data contradicts the null hypothesis, suggesting alternative hypothesis is true. Okay, previous our example, diabetic patients with peripheral neuropathy. So duration of diabetes is a continuous measurements. So here the test one, for example, here in this example we are using student's T test because two independent samples. One is peripheral neuropathy, some 20 patients, no peripheral neuropathy, some 80 patients, 20 patients of the duration of diabetics and 80 patients. So it is a continuous variable. We are using T statistics, students T test statistics. The test is conducted. For what purpose they are conducting? We are conducted the test to investigate whether the data contradicts the null hypothesis. What my null hypothesis says, there is no statistically significant difference of peripheral neuropathy and non-peripheral neuropathy with respect to duration of statistics. Suppose my probability value is greater than less than 0.05, then automatically I am contradicting my null hypothesis. I am saying that my null hypothesis is false. My alternative hypothesis, that means there exists a statistically significant difference between the duration of statistics mean with respect to peripheral neuropathy and non-peripheral neuropathy patients. Okay. This is the for investigation. So detail will be there. Here I am giving an example to understand our introduction of statistics, overview of statistics in a better manner. Then only you will have interest and you look to all my totally I will have more than 30 or 40 videos. That means YouTube videos will be uploaded. That we don't know. But whatever it is, next time I am going to tell about p-value and other thing in my next chapter. Thank you. Bye. Good day. Ram Ram. Jai Ram.